Hello everyone and welcome to geometry class. This is our first chapter, chapter 1, Foundations for Geometry, and within this chapter we're really going to be setting up all the concepts and things in geometry that you need to know to be successful for the entire year. And here we go, 1-1, that means chapter 1, lesson 1. That's the first thing we're going to talk about, understanding points, lines, and planes. So those are the things we're going to be discussing today in class. So first I want you to do these warm-up problems. These are inequalities, and I just want you to go ahead and graph those. This is just kind of a review. And so I have my friend here. This is the pause dragon. And whenever you see this pause dragon, what this is just a virtual cue to get you to remind you to pause your device, go ahead and work out these problems 1, 2, 3, and then when you get done, press play and listen to the explanation. So go ahead and pause, work on the warm-up, and I'll see you in a little bit. All right, let's go ahead and see how you did. So for this warm-up, x is greater than or equal to 3. Let's go ahead and graph it. So to graph it, we're going to make a number line. Ooh, I wish that number one line was a little straighter, but that's okay. We'll go with it. I'm going to put 0 here and 3. So 1, 2, 3. 1, 2, 3. Now, whenever you're dealing with inequalities, you have greater than or less than signs. And you have to know that when you graph those, you use a open circle. And then when you have less than or equal to, or greater than equal to, or less than or equal to, you have a closed circle. And the thing I love about these is I think they just make the cutest little math emojis. If you go ahead and make a little circle and just give them a little bit of hair or something, I don't know. Maybe this one will have some curly hair. And I just think they're just the cutest little things. Okay, but anyways, this is a greater than or equal to, this is x is greater than or equal to 3. So we're going to be using that closed circle. So we put that closed circle on 3. And this represents x is all the solutions that are greater than or equal to 3. So from here, what are the numbers that are greater than 3? Well, it's everything this way. So that means x is everything, including 3, all the way that way. Okay? Let's move on to this next one. So we have x is greater than or equal to 2 and less than or equal to 6. So we're going to go ahead and graph this. And this is what I like to call an AND problem. So I'm going to put 0 here, and then 1, 2, 3, 4, 5, 6. And x is greater than 2, and that's a greater than or equal to. X is greater than or equal to 2, so that's going to be our closed circle there. And then x is less than or equal to 6, and that's also a closed circle. And then x are all the numbers in between. So x is 2, 2.2, 2.3, 2.4, 2.7896, 3, 4, 5, 6. Everything, every little number that can be in there. There's an infinite amount of numbers in there, right? And that's what x is. Okay, now for the next number, we have x is less than 1 or x is greater than 0. X is less than 1 or x is greater than 0. I really think this is not written correctly. Okay, so this isn't right. I'm going to rewrite this. This is supposed to be x is greater than 1 or x is less than 0. So just go ahead and rewrite that, okay? So this is an OR problem. And so we're going to write this right here. So whatever you did, just go ahead and erase it. So make sure that you're always doing your notes in pencil, okay? And so we're going to put that 0 here. Where's our 0? Here's our 0. Our 0's here. And then we'll have 1 here. So x is greater than 1. Okay, so x is greater than 1, so all the numbers that are greater than 1 are that way. And it's an open circle, right? Or x is less than 0. And all the numbers that are at less than 0 are right here. So that means x can be anything over here that's less than 0, or x can be anything that's greater than 1. So that's how you do those inequalities. All right, so let's start talking about, that's a great warm-up. Let's go ahead. I hope you got those problems right. If you didn't, I know this one was kind of messed up. So, but hopefully you got these two. Go ahead and change your answers and so that they are correct. Okay. Let's look at the vocabulary terms. Okay, the first one we're going to talk about is undefined terms. So undefined terms, what those are the most basic figures in geometry which cannot be defined by using another figure. Like, you can't define it by using another figure. So like a point. You can't define a point by using something else. That's just the most basic thing that there can be. A line is the most basic thing there can be. A plane is the most basic things. So these equal the building blocks of geometry. So everything is really built off of these concepts. So let's say we talk about like a triangle, right? So a triangle is really, you know, you got 3 points and you have these different line segments connecting them, and then there's a plane. So a triangle actually can be made up of points, lines, and planes. You can describe it that way. All right, but a point, you can't describe anything. A point is just a point. A line is just a line. A plane is just a plane. So let's talk about these building blocks of geometry. The first one is a point. The point names a location and has no size. So we could have something like this, point P. And this would be the symbol, or you could write it in words and it would be point P, like that. Okay, so you'll have to do this both ways in your homework assignment. Okay, for a line is a straight path that has no thickness and extends forever and ever and ever. So here we have a picture right here of a line right here. And there's a couple different ways to write this. Okay, so we can use it using symbols. So we can say X, Y, and then you have this symbol where there's like this little itty bitty line. It has to extend in both ways, and that means something. It means that the line goes forever and ever in the direction of X, and it goes forever in that direction and ever in the direction of Y. Or you can write it as YX, like that. So the alphabetical order doesn't matter. However, I always like to keep it in alphabetical order. I think that's the best way to do it. Or right here you see this kind of like cursive L off to the side. Sometimes they just call it line L. So those are 3 different ways to write this right here. Okay, cool. Now let's talk about the third building block of geometry, which is a plane. A plane is just like a flat surface, okay? So this right here, this table, this is a plane. The ceiling is a plane. The floor is a plane. Any flat surface like a computer screen, that's a plane. Okay? So a plane, that's a flat surface that has no thickness and extends forever. All right, so here we have a little image of a plane. So let's go ahead and figure out how to write the symbols and how to describe this plane. So whenever you use the symbols for plane, you need 3 vertices. Okay, this is a point, 3 points. This is a point, this is a point, this is a point. This is not. This little like cursive R thing, looking R, that's not a point. You need a point for it to be a point. So we could call this plane A, B, C. So remember, you're going to have a quiz. And so it's 3 points, not 4, just 3. Okay, so that would be one way to say it. Or you could just really do it in any order, like plane, you know, C, B, A. It means the same thing, right? The order of the points it doesn't matter. But I always like to just have them in alphabetical order. It's the most straightforward. It goes with the answers in the back of the book and the tests and the quizzes and things like that. So that's how I do it. Also, you could just write it like this. Plain R. Like that. Plain R. I try to do a fancy R. That would be another way to describe this plane. So those are some different ways to do it. Okay, cool. All right, the next term that we're going to use, and you're going to use this a lot in this class, is this concept of collinear. Collinear, those are points that lie on the same line. Points that lie on the same line are collinear. So let's look at this. What are some points that lie on the same line? So what we could say is we could say K and L. Those are points that lie on the same line, K, L, and M. So these are collinear points. So K, L, and M are collinear. They're points that are on the same line. However, K, N, and M, so K, N, and M are not. They are not on the same line, so they are not collinear. Okay, just an example of something that's collinear and something that's not collinear. So you can't draw a line through K, N, and M, but you can draw a line through K, L, and M, a straight line through all three of those points, which means that they are collinear. Okay, we talked about collinear. Let's go ahead and talk about coplanar. Coplanar are points that lie on the same plane. Okay, so points that lie on the same plane. So right there, A, B, and C up here, those would be coplanar points. All right, let's go ahead and talk about our first example. So in this example, example number 1, we're just going to be looking at this figure and naming points, lines, and planes. So the first thing we're going to do is name 4 coplanar points. So 4 points that are in the same plane. So let's look at it. What are 4 points that are in the same plane? Well, I see this bottom plane right here, which is a rectangle. That's a plane. I also see these kind of like triangular type planes. They're kind of tilted right there, A, D, and E. That's a plane. A, B, and E, that's a plane. B, C, and E, that's a plane. And there's also a back plane, D, C, and E. So there's actually 1, 2, 3, 4, 5 planes, but we need one plane that has 4 coplanar points. These ones all tilted on its side, they all have 3, but the one on the bottom, that has 4. So the 4 coplanar points, where all the points are in the same plane, would be A, B, C, and D. Okay, those are 4 points that are coplanar. Okay, so now let's go ahead and name 3 lines. Well, we could probably write this better. We'd probably say point A. We probably should say point A, B, C, and D. That would probably be more accurate. Point A, B, C, and D. So don't write it like that. Put point on the front of it. Point A, B, C, and D. Okay, 3 lines. So go ahead and let's go ahead and figure out what 3 lines are. Remember, a line is something that goes in infinite in one direction or the next. So what about this? Would BC, would that be a line? Does it go forever and ever, ever this way? No, it goes there and it stops. And it goes this way and it stops. It doesn't keep going on and on forever. So BC would not be a line. However, if we look at EC, look at that. It goes on forever and forever and ever. So that, and it goes forever and ever this way. So I'm going to say CE, that is one line. So I'm going to write CE and make a little line symbol on top. What's another one? What about here? AE. Yeah, it goes forever this way and it goes forever and ever that way. So AE would be another one. Another line that goes forever and ever in each direction. What about AB? This right here, this line, AB. Does A keep going? Nope, it stops there. Does it keep going this way? No, it stops. So that's not a line. It doesn't go infinitely in both ways. But how about DE? Yeah, DE goes forever and ever that way, and forever and ever that way. So that would be, DE would also be a line. But there's one other one. Did you guys guess it? Did you write it down? It's BE. BE goes forever and ever that way. So that's the fourth line. You only had to do 3, but there are 4. So I just wanted to write that unless somebody else did that one. Okay, perfect. All right, we are going to go to the next page. And CIO, that means check it out, example 1. So this is your opportunity to go ahead and, well, we're just going to do this one together because we haven't, I don't think we've talked about planes, name 2 planes. So let's go ahead and do this. So we'll do this one together. So there's planes here, there's planes here, and there's planes here. So let's go ahead and write name 2 planes. So if I wanted to talk about this plane right here, remember I need 3 points. So A, B, and C. So I could say plane A, B, and C. Or I could just do it in a different way, but remember I always like to do it alphabetical. I could say, oh, plane C, B, A, right? That means the same thing. It's not like this one's right and this one's wrong. Any order, it's okay, but I always think it's best to do it alphabetical. Okay, so that's how you could write that one. What about this one? Remember here, there's 1, 2, 3, 4 points. But how many do we need? How many points do we need to write a plane? We only need 3. So we could write this as plane KNM. Or we could use a different 3, plane LMN. Or we could just write it plain and see that little symbol right there. Do it this way. That one was better, plain R. And there's other ways to write it, but those are just some, so it gives you the idea. So plain, you write the word plain, and then you write 3 points that are all in the same plane. Or if it has a symbol like that, you can just call it plain R. All right, perfect. Well, good job. That is example 1. So I'm going to have it ahead and stop this video, and then we'll be back for example number 2. All right, see you in a bit.